we're going to look at in this lesson is arithmetic sequences. But first, want to take a quick little detour and talk about some of the implications behind all that credit card and mortgage problem things. So here's a few statistics here. So a study was released, found that women pay higher interest rates on average on their credit cards compared to men, and the difference doesn't disappear with financial education either. So female cardholders with low financial literacy are more likely to engage in 2 or more negative payment behaviors than their male counterparts. So both sexes with high financial literacy make 2 or more negative payment behaviors at the same rate, the study found. So that's one interesting thing there. Some of these are a little bit older, from the fall of 2010. Last time I did this class, some of them I kind of updated a little bit with a quick search. Some of these numbers are, a little bit all over the place because they're really approximations, but at least it gives you an idea where they are. So this one, total consumer credit, 2.5 trillion as of December 2011. If you actually look into student loan debt or credit, I forget what the number is, but it's student loans are way more than credit card debt, and that's been in the news lately. So credit card debt by average American, about 9,000 here. That number varies some, but still quite high. Finance charges paid in 2001, 50 billion. So that's basically if you paid your bill every month, you wouldn't have these finance charges. GE Rewards came out and said paying off your credit card balance each month may actually start costing you. So MasterCard holders who paid off their entire balance in a timely manner were penalized $25 because the bank was not making money off of them. I mentioned to you, I pay mine off every month and always have, and my rate on mine went up a year or so ago. Average American household credit card debt in 1990 was about $3,000. 2007 was about 10,000. And then this is a link. You can get some of the other stuff and also some of these as well. Here's a chart showing total consumer credit outstanding from the 1940s in billions of dollars up through where we currently at. The gray areas are recessions. So you can see it's clearly an exponential growth type thing here, and quite shocking numbers there. Okay, so arithmetic sequences. We know what sequences are, and we have two different formulas to define them. So recursive formulas, they always have 2 lines. So you need the first term, you need the nth term. Really easy to create sometimes. But if you want the 50th term, you have to have the 49th term. So we also have explicit formulas, which is just the t sub n equals n squared plus 1. So if you want the 50th term, you literally just plug in a 50 for the n. Arithmetic is defined like this. Okay, and you can think of arithmetic as basically being linear lines. So you could just as easily turn everything we're going to do into a y equals an mx plus a b. Okay, arithmetic sequences use this though, and what it says, this is your nth term, so whatever term we're looking at, 1, 100, 1,000, whatever. Okay, a sub 1 is obviously your first term, and remember sometimes I may use t's for these, it really just depends which book you have. N, that's just the number of the term you're on. That number corresponds to this down here. Okay, so a sub n is different than n. If you want the 50th term, you would plug in a 50 there. Okay, and d is the common difference. That's what that is. So if you distributed the d and you collected like terms, you end up with a line. Okay, arithmetic have to be linear. So you have to think of them as they have to have slope, or something's got to be constant with it. Okay, an advantage of doing these in this formula is if we wanted to find the 50th term, it's really, really easy to do that. Okay, so everything you see here today will go up by the same amount every time. Okay, it can't be any quadratic, it can't be any multiples, we can't go plus 5, plus 7, plus 9. Okay, that's not arithmetic, it's got to be constant. So let's say I give you this arithmetic sequence here, 4, 1, -2, -5. You want to find the 20th term. Yeah, you could sit there and you could count them all out, but if I change it to the 200th, that wouldn't be quite so fun. So you look at this, getting the patterns are pretty easy. You're saying, well, it's basically going down by 3 every time. So you get a formula, a sub 1's easy. Grab that for the first term. Common difference is -3. So there's your equation. That equation right there, and you can simplify it if you want or keep it just like that, will give you any term. So if I want the 20th term now, and it's -53. Okay, that makes sense because you should keep getting smaller and smaller and smaller. If you got an answer bigger than 4, you know you did something wrong there. And again, it's just a matter of being careful and plugging in things where they need to go. Okay, so the n is going to be the number of the terms here. Okay, the a sub n will designate what the 20th term is. Okay. Next, what if I told you the 6th term of an arithmetic sequence is 31 and the 19th term is 109? Then I asked for the 15th term. So there's not just one set way to do this. There's really one that's going to be easier than the others. So the key is I tell you it has to be arithmetic so you know there's a common difference. Okay? I'm telling you term numbers here with 6 and 19, and I'm telling you actual values here as well. Okay? So what I know from this information is a sub 6 is 31, and a sub 19 is 109. Okay? All we know for arithmetic ones is this equation here. You could probably turn this linear if you wanted, but it's really going to be the same thing as using this formula. Okay, so let's set up everything we can. A sub n, what if I wanted to do an a sub 6? I know that value. So I'm going to say 31 is my 6th term. I have no idea what the first term is. I know this n has to be a 6. Okay, I'm going to do the same idea for the 19th term. I'm going to say a sub 19, which I know is 109, equals the first term. Still don't know what it is. The 19 goes in here for n again. So this is times 18 times d. If I clean these up a little bit, I get 2 equations, 2 variables. You get a ton of different ways to solve it. I'm just going to do this. It's probably the easiest. This is simple elimination. A's will cancel. You'll get 13d here. This should be 78. And you just found the common difference to be 6. Once you know the common difference is 6, plug it into wherever you really want to. This is going back to just solving systems here. I'm going to use the original. Okay. Looks like we just solved for a sub 1 and difference. Okay, part 2, we'll bring this over and we'll finish this problem up.